So in question 1, Class A has 23 students and Class B has 29 students. How many lineups are possible if Class A lines up first? So since Class A has 23 students, that means there are 23 ways that Class A can line up. Now we also have Class B. And so we multiply by the number of ways that Class B can line up. Now for right now, all we're doing is working on setting up the formula. You already know how to find these values using factorials, using your calculator. What's more important is to note that, okay, Class A has their number of lineups, and Class B, independent of Class A, has a different number of lineups. And so from that, we multiply them. It's just like the example today, where if you have 2 sets of pants and 3 shirts, how many outfits? 2 times 3, because pants and shirts, you have that, and you multiply to get 6. Same way here, you multiply this times this to get your answer. Now, number 2 adds in a Class C. Now, we still have Class A, and we have Class B. But now we bring in Class C with 18 students, and we're going to have all 18 of them line up. But notice what it doesn't say. In number 1, it says Class A lines up first. But now the classes can be in any order. So that means we have to include, well, how many ways can the classes themselves line up? Well, there are 3 classes, and they're all lining up together. So that means it's 3p3, 3 different classes, and we're lining all of them up. Now, number 3, you've seen problems like this before, where we have a given number of things that go into a meal: appetizer, entree, side, dessert. It's just like the outfit idea. And so to figure out if I choose 1, then it's 3 times 2 times 5 times 3. That's the number of meals that are possible. But what if we have more than one choice? Now it gets a little more complicated. So here in number 4, how many ways to pick 2 appetizers out of 3 choices? Well, the order doesn't matter. So that means it's going to be 3C2. How many ways to pick 5 sides out of 5 choices? Again, order doesn't matter. The order that they bring the sides doesn't matter. So that's going to be 5C3. So here, number 6 asks, how many meals are possible if you choose the following? So, how many ways can I just pick my appetizers? 3C2. How many ways can I pick my entree? 2C1. How many ways can I pick my sides? 5C3. And how many ways can I pick my dessert? Well, that's going to be 3C2. And we would multiply them. Now, if I go back to the previous one that we did up here, why don't we do the same thing here? Well, actually we do. It's just we don't need to, because in each case, we're only choosing 1. So for appetizers, it's 3 choose 1. For entrees, it's 2 choose 1. For sides, it's 5 choose 1. And for desserts, it's 3 choose 1. And anytime you're only choosing 1, all you need to do is look at the number that you're choosing from, and that's the number of outcomes. But as soon as you choose more than 1, now, like down here, now we have to use the permutation and combination notation. Number 7, 4 people are chosen from 4 males and 6 females. How many teams are possible if 3 females are chosen? Okay, so that means we're choosing, out of 6, we're choosing 3. Again, it doesn't matter because this is a team. But we still have a male to choose. So we have to multiply by however many males are chosen. So that's 6C3 times 4C1. So if it's 2 females, then it's going to be 6C2 times 4C2. This is the number of ways I can pick the females, the number of males, and then the team in total is what we get when we multiply. Now, if there's one female chosen, then it's going to be 6C1 times 4C3 for the females and the males. And then finally, if no females are chosen, that's going to be 6C0 times 4C4. Okay. Now the last example, number 8. A deck of cards has 52 cards. Now, if I deal the same 5 cards but in a different order, is that a different hand? No, it's the same hand. So how many different hands are possible? That's 52C5. Now, how many card hands are possible if they are all face cards? Now, there are 12 face cards in a deck. So, a lot of people think that the answer is 52C12. But what they do is they have that idea backwards. Instead, we're still choosing a 5-card hand, so it's something C5. But if we're all face cards, that means we're only picking not out of the 52, but only from the 12 face cards that we have. So that's why it's 12C5, because there's only those face cards to choose from. All right, now letter C. How many different 5-card hands are possible if 1 card is an ace and 4 are kings? Now, if you don't know, there are 4 aces and 4 kings in the deck. So 1 card is an ace. So how many ways can I choose that? Well, there's 4 aces, and I'm picking one of them. And then how many kings? There are 4 kings, and there's no such thing as K. So it's 4C4 for the number of kings. And so for the number of aces, there's how many different ways I can pick 1 ace. Here's the number of ways I can pick 4 kings, so we multiply. Now, letter D, it says how many different 5-card hands are possible if 4 cards are kings. So we know that 4 cards come from the kings. And a lot of people would stop there. But the problem is there's still 1 card left to account for. And the thing is, where's that card coming from? Well, it's not a king. So the question is, how many cards are not kings? 48.